Hello everyone, I'm Ryan here, and here comes another video. Really unpredictable schedule of videos. But now I finished my exams, I really have nothing to do. So I hope, so I thought, why not use this period of time more productively and effectively, and ultimately maybe help the community of pre-med students. And the aim of today's video and maybe a couple videos that follows is just to go through a couple questions and see how I approach these questions and what strategies I used, and just to show everything to you guys. So it not only to provide you with some insights in of the actual ISAT, but also at the same time, I hope you guys can learn a little bit from how I approach these questions in order to improve your efficiency and your accuracy when you are doing those questions in the near future. So yeah, although it's not very structured videos, it's just more like a lecture or just like a private tutoring. You just can treat me as your recorded video lessons, I suppose. Yeah, but I do hope that you guys can find it helpful. I'll try to put as much resources out there for the next 8 weeks. All right, so how about we just get into the questions? All right. Another thing I want to say is if you want to download this document, I'll put a Google Drive link into the description of the video. All right. For quantitative reasoning, I think it's very different from crit. In that sense, there's not too much reading involved. You're usually dealing with numbers, graphs, charts, tables, and those things all have one thing in common is that the most important pieces of information are contained in the title and also the units that you see. Seeing this question, I know that it's going to be a quant question. It has some sort of graphs involved, some numbers. So I know it's probably a quant question. Then all these words, these text is not something I'm particularly interested in. And how about we just cross them out? We just don't refer to them at this moment. If there are questions where we feel like, okay, we have to refer back to the those introductory information, then we can do that by searching keywords. But for now, let's just ignore it. However, it's not the same that if you ignore the text, then you just jump straight to the question. Because for all graphs, sort of quantitative reasoning questions, you have to make sense of the graph, right? In this case, I said the two most important things are the title and the units. And what we see here is we see on the x-axis is the increase in trunk diameter, right? So increase in trunk diameter, and on the y-axis, what we see is species 1, species 2, species 3. So that means we have 3 species of something. It doesn't really matter what they are, but judging by the word trunk, we probably can assume they are some kind of plant. They're probably trees, right? And also we see another difference between those 3 species is the use of different, I guess, those rectangles, right? You can see some are solid color, some are stripes. So by referring to the legend over here, we can see that the stripes are trees planted in full sun, and the shades are trees planted in part shade. All right. So what does this tell us? I think we can probably see the 2 pieces of critical information from here is that the independent variable in this experiment or in this study is the condition of growth. Is the condition of growth. So some trees are planted in the full sun, some trees are planted in the part shade. And for people out there who's doing sciences, I assume that you guys understand for any experiment, you need an IV and you need a DV, right? So what's the DV? DV or the dependent variable is something that we measure. What's something that we measure? Obviously, it is the increase in truck diameter. So that's the DV. So really what we have is we have three groups, species 1, 2, 3, and within each group, they are exposed to different conditions. And what we measure is the increase in truck diameter. Right. So that's everything we sort of learned from this graph, and we know how to interpret it. In the real setting, it's probably going to take you 1 minute. Though I've taken longer because I sort of explained verbally of how you would go about it. But realistically, that will take you 1 minute to understand, or 1 to 2 minutes, actually. 1 to 2 minutes to understand what the graph is trying to tell us. If it is an experiment, so the important elements are IV, DV, and CV. CV stands for controlled variables. Okay, so now we made sense of the graph. How about we just look at the questions? So question 4 over here, it asks for how many trees planted in full sun survived for 12 months. All right, so how many? The first thing we got to think about is the condition, right? The condition, it tells us it's in full sun. So in full sun, we can refer to these ones, the stripes over here, right? And another word is survived. So for a plant to survive, obviously they have to grow, right? If a plant doesn't grow, it's probably not going to survive. So over here, it's basically telling us to count the number of these striped these rectangles that has stripes in them, right? It's basically everything you need to do. Just count the number of stripes. So we have 2 here. Sorry, I'll probably use a different color. So we have 2 here, and plus 3 over here, we have 5. And plus 1 over here, we have 6. And over here, 8. And then 9. And then plus 3 over here, 12. And plus, okay, so now it's interesting, right? We see this one over here, it's a bit flat. And by referring to the legend over here, we can see the flatter ones actually stand for 50 instead of 100. So what we do is, how about we just take 0.5 for the flatter one, right? So we have 12 and we have 1.5 here essentially. So that adds up to 13.5. And then over here, 14.5. And then 16.5, 17.5, 18.5. And then we have 4 here. So it will be 22.5 and then 24.5. So although we counted 24.5 rectangles, but each rectangle is sort of what? 100. So we need to multiply that by 100. And what that gives us is 2,450. 2,450, which is C over here. As you can see, as long as you understand the graph, the introductory information is pretty much useless. You can do the questions. It's just about counting and doing some simple math. It's really not that hard. So, all right, moving on to the 5th question. Which of the following could be planted in order to grow a forest of trees with the greatest spread of trunk diameters? So a keyword being introduced here is the word spread. So for people who have done statistics in the past, you probably are familiar with words such as median, which is a measure for what? Measure for center, right? Measure for center. And other things like standard deviation or variance. Oh, that's variation, sorry. Variance. So those are the measure for what? Those are the measures for spread. So what basically it means is that in a set of data, we can have, so if your population is big enough, usually we would have a normal distribution. And a common example of a normal distribution is the IQ curve. And basically what it tells us is this line over here, the center is, for example, for IQ would be 100, which is the average or the mean or the median in that sense of a normal distribution of IQs within a population, which is 100. And what is variance? Variance is basically how far away you can go from the center of the statistics. So over here, you probably have -1 standard deviation, and over here, you probably have +1 standard deviation. So those are the things that measures for spread. So let's just compare, right? Let's just think about this. This is a case of normal distribution, but sometimes what we get is we have a really narrow curve, or we can have something like this, right? So those two things, basically, just by looking at them visually, the first curve has a smaller spread, because basically from its mean, the standard deviation is a lot less than this curve over here, which is probably like this, right? You don't need to worry about how standard deviation is calculated. It's never going to be examined on the ISAT, but it's just something to keep in mind about what spread is. What is the measure for center? What is the measure for spread? And basically, it's asking us, okay, so which of the following should be planted to ensure a greatest spread? So that means basically it's telling us that we will have a greatest variation of truck diameter, right? So if we refer back to this graph over here, let's just delete everything. If I were to draw a sort of a distribution curve for these species, then species 1 is probably going to look like this, look like that, right? And species 2 is probably going to look like this and that. And species 3 is this and this. So just looking at these curves, you can see that it is species 2 with those solid rectangles that has the biggest spread, because you have trees that it has 6 millimeters in diameter, but also you have trees that are 35 millimeters in diameter, which is a very, very big variance between the smallest value and the biggest value. So as a result, it's pretty clear to us which of the following should be. It should be species 2 in part shade, right? Species 2 and in part shade. So this one over here. All right. Forgive my terrible annotations. It's just very, very messy. Okay. Sorry, I didn't. So that's C, and this is also C. For question 6, it's asking us another thing, which is the average, right? So this is the keyword over here. This question is asking about the average. So remember when we talked about a normal distribution curve, usually the average is around, or in this case, you can call it a mean or a median, is around the center of the curve, right? So let's look at, so this is asking us for the greatest average, because we need a fastest growing tree. And so we need the average to be the greatest. And by looking at these, by looking at this graph, we can see, okay, so what are the possible two greatest averages? For example, let's just take species 1 again. If we were to draw a distribution curve for 1, then we can probably see the center for species 1 in full sun is around there, right? So it's basically this dotted line. And it compared to something like, I don't know, just species 2 in full sun, we can probably see the averages over here. So we can see the averages visually being represented is that species 2 in full sun is going to have a greatest average than species 1 in full sun, right? So by applying this same principle, then which one do you think has the highest average? Just by visually looking at it, what I would say is either it will be species 2 in part shade, so this one, or species 3 in full sun. Why is that? Okay, so let's have a look. If I were to draw a distribution curve, So we start off, sorry. So we start off pretty high. So we start off pretty high and then dips and then we go up again. So that's the distribution curve for species 2. And what about species 3? Species 3 in full sun is probably gonna look something like this, right? So you start off a bit like medium, and then towards the end you sort of have that bump, and then sort of decreases quickly to 0. Why do you think I picked those two curves? Is because the median obviously is going to be like in the center of these curves. And in the center of these curves, we can see it's probably for species 2 in part shade, it's probably like over here. But we can't really tell where exactly that is. In species 3, we can see is probably going to be somewhere like here as well. So this presents us with a difficulty where we can't sort of use shortcuts. We can't just visually look at them and differentiate which one has the highest average. So that means some accurate number manipulation has to be used. So the first, I want to just reinforce people's understanding of how we calculate mean, or average in that sense. How do we calculate average? Average is basically the sum of all things over number of things. Right? Sum of all things divided by number of things. So in this case, how do we do that? How do we do that? Because basically what it gives us is a range, right? And we can't really work with a range when we calculate a median. So basically what we can do is we can separate them into discrete chunks. So instead of thinking about them in a continuous sense, how about we just assign them a random number? Let's just say the first grid is 1, and then that's 2, that's 3, that's 4, that's 5, that's 6. So instead of working with continuous numbers like a range, we can just assign a random, but in order, right? So in increasing order of values, we assign to each block, and then we can calculate the mean from there. So yeah, with that being said, how do we calculate the mean for species 2 in part shade? We have 3 that has the number 1, so 3 times 1. And then we have 0 over here. And then we have 3 times 1 again, because of this one over here. 3 has a number 3, but we only have 1 block, right? And then plus this one over here, we have 3, and they assign the number 4. So 3 times 4, and plus what we have 2 rectangles, and then we have number 5 assigned to them, and then plus number 6, 1 times 6, and divided by 10 rectangles. Right? So if we do the calculation over here, we can probably get something like this is 3, 12, 10, 6. So 18, 28, 34, 3.4 is the mean for species 2 in part shade. Then we just need to do another set of calculations for this one over here for species 3, but in full sun. So what we have is the same principle, right? We have two rectangles. They assign the value 1 plus 1 times 2 plus 1 times 3 plus 4 times 4, right? And then run out of space again. So plus 4 times 4 plus this 5 times 2, right? So, and it's divided by 10 as well. 10 rectangles in total. So 2, 3, 4, 8, 10, right? So what we have here is we have 2 plus 2 plus 3 plus 16 plus 10. And that gives us 4, 7, 3.3. That gives us 3.3. So comparing these two numbers, right, obviously it's only by 1 decimal place. However, we can tell that it is species 2 planted in part shade that has the greatest average. Yeah, this question definitely took a while. Obviously, you can see the calculations involved are pretty easy. As long as you graduated from high school, I can probably guarantee that you can calculate this. It's primary school math, but it's just about finding the right piece of information and how to do it um, under really big time pressure, right? So this is why we sort of just ignored the information above, like because reading that takes time and it's not really relevant to all the questions that we've been doing. So I feel like, yeah, this is how I would approach these questions. And also the last question. So what fraction of trees planted did not survive for 12 months? This is something new. So trees that have not survived. So all the trees that are represented in the graph must mean it must mean that they have survived, right? So how do we calculate a fraction? We know that a fraction requires what? A fraction requires basically number of trees survived divided by what? Total number of trees, right? Total number of trees. And we know just by referring to the graph, obviously, we can find the number of trees survived just by sort of adding up those rectangles. Yeah. But it's the question becomes how do we find the sum of all the trees? So the total number of trees. And this comes to the additional information that we have 2,000 trees per species, right? 2,000 trees per species. And as you can see, this is really the only piece of additional information we need from this text. Right? So that's why I said, don't read the additional information unless you encounter something that you feel like, okay, I have to find it somewhere. And in this case, we are reading this background information with the aim or with the intention to find the total number of trees. So we look for these keywords and instantly we can find that we have 2,000 trees in total, right? Or 2,000 trees per species. So what does that give us? We have 2,000 for species 1, 2,000 for species 2, and 2,000 for species 3. So what we have in total would be 6,000 trees. 6,000 trees. And then it's just about counting all these rectangles up again, which takes time. Very annoying process, I know. But if anyone can think of another way to sort of more efficiently count those rectangles, please just comment down below, because this is a very annoying process and it's something that I feel like it's just I have to do it. Yeah, so count the number of trees or a number of blocks in this graph and then divide that by 6,000. And because I can't be stuffed to do it now. So the answer for this one is A, 106. Oh, sorry, it is asking for did not survive, right? So did not survive, obviously. So that's why reading information or reading the question is very important. So this is basically what we get is the fraction for trees that survived. So in order to get the trees that did not survive, we just need to use 1 minus whatever this is. So 1 minus x is 106. So that means the fraction of trees survived must be 516. All right. So I think that's everything I want to talk about for this question. Just in sort of I introduced or I sort of revealed some key concepts in statistics and on how in many quantitative questions you don't really need to read the background information. It's just about the title and the units. In this case, units isn't really important, but it's just about finding the title. So these titles can help you to identify the independent and dependent variables in that sense. And by using those independent and dependent variables, we can deduce how the experiment is set up and how, what are we measuring? What is the aim? The aim is basically just look for conditions that favors trunk growth. Right. So moving forward to next set of questions. You guys can do all these questions just in your free time. I'm not going to go through these questions with you. How are we going for time? Oh, actually, I can't really see. So whatever, let's just continue with this question. Over here, it's I'm gonna reinforce the idea that these information, most of them are not important. So we just go straight into the graph. And looking at the graph, we can see three things. What three things? We have on the x-axis, we have the DCC. On the y-axis, we have the MHP, right? And note that their respective units are dollars and kilometers. And what we can see is another thing that shows us it's different times, right? So we have 1990s, 2000, and 2010s. And those are represented by differently shaded rectangles. Right, so that's pretty much everything we need to know, right? So basically it's telling us, you know, for 3 decades, that's the MHP for each sort of DCC. So how about we just look at one? So maybe let's just say, okay, so in 1990s, if you have a DCC of 20, then what is going to happen is the MHP is what? The MHP is basically this one over here, because it's 1990s. So the MHP is $150,000. Right, $150,000. That's basically everything the graph wants us to know, and by understanding that, we can just move on to the questions. Question 29, of the following, which showed the largest average annual MHP increase? All right, so now we understand what the graph is trying to tell us. How about we just move on to the questions? And question 29 asks us, of the following, which showed the largest average annual MHP increase? So what's the variable that we're interested in? MHP, right? So basically it's asking us for what DCC, and for what period of time, do we see a largest MHP increase? So really there are two ways of doing this question. The first way is the dumb way, is we just check the individual MHP increase for each of the following options. But that takes time. So what's a smarter way of doing this? So this is checking individual options. And the smart way is what we call what is the difference between options, and use these differences to deduce what is likely to be the correct answer. So just by looking at these options over here, we have 35 and we have 40. So that doesn't really tell us much. But what actually tells us much is the time period, right? So for option A and option C, it's 1990 to 2000. It's only what, 10 years, 10 years, okay? However, if you compare that to option B and D, what is that? That is 20 years, right? 1990 to 2000, 2000 to 2010, that'll be 20 years. So just looking at this graph over here, we can see that in 20 years, the increase is definitely going to be higher than the increase in 10 years, right? This is increased in 10 years. This is increased in 20 years, right? So just by looking at this piece of information, the difference between those two options, then we can probably rule out A and C. So it's just about looking at how much 35 versus 40 has changed or increased during this time period. So let's just identify, right? So 35 is here, 40 is over here. So in 20 years, from 1990 to 2000, to 2010, sorry, is that this one increased by this much and this one increased by that much. Okay, so zoom in, you can see that they reach the same highest for both 35 and 40. However, the starting point of 35 is greater than the starting point of 40. So what that means is what? Which one has the highest increase? It's definitely just option D, right? 40 kilometers from 1990 to 2010. So easy, easy question. So moving forward to question 30, from 1990 to 2010, so 20 years, what was the change in the minimum DCC that could be afforded by a house buyer on an average income? Well, what is being asked? Is the minimum DCC. This is the variable that we are interested in. Let me use a different color. So minimum DCC is what we're interested in. And also that can be afforded by a house buyer on an average income. Then I don't know, because DCC doesn't tell us about affordability. MHP doesn't tell us about affordability. So that means there has to be something else that we need to identify from the additional information. And yes, looking at this, so on average income, which is the keyword we're trying to search for, is that we have this idea called AHA. And AHA is basically how much a person can afford. So this is another keyword, which is afford. So a person on an average income can afford to pay for a house. And we know that AHA was 150,000 or 150,000 in 1990, and that increased to 200,000 and 400,000. All right, so what's the change? So from 1990, we know that, what is it? AHA essentially, which is affordability for a person on an average income, is what? Is not $150,000. And what about 2010? What has changed? This changed to $400,000, right? So basically, we think about this. This is dollar signs. This is dollar signs. So there has to be on the y-axis, being represented on the y-axis because they use the same units. So in 1990, that will be $150,000, which is around here. Right. So this is the minimum this is the minimum DCC you can afford to buy in 1990s. Right. And the DCC is what, 20 kilometers. However, that changed to $400,000 in 2010, and 400,000 is over here. Oh man, that's such a change. Okay, and not, right? Because we're looking at 2010. Remember, 2010. So 2010, you would have something like a 35 kilometers is the minimum DCC you can afford, right? Because you can't really afford anything above, right? You can't really afford those things. These are too expensive than your average income. So what you can afford is essentially 35 kilometers away from the city center, which is DCC. So what's the change? What's the change? The change is 35 minus 20, which gives us 15. So what's the key takeaway from this question? What's the key takeaway? The key takeaway is that if we see information that they require us to identify, but we don't know, like we never really thought about average income when we interpreted those charts, then we have to find that from the additional information. And the way we do that is just by looking at keywords. Average income, afford, average income, afford. And that brings us to the idea of AHA, which is the second point I want to make, is that AHA has the similar, not similar, it's exactly the same unit being used by MHP. So what that tells us is it has to be on the MHP side, right? So they use this same units. So yeah, so it's a similar, same thing, right? Title and units most important things in ISAT. 31. Which of the following years did a person on an average income have the greatest choice of DCCs to from which to buy a house? So what it's asking us is which year, right? Which year? So let's think about this. For 1990, the AHA, which is the affordability, right? So they can buy a house means they can afford it. So that is alluding to AHA. And in 1990s, AHA is $150,000. And that's this line over here. So what are the DCCs they can buy? They can buy this one over here, right? And also they can buy this one. 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 And they can buy this one. So how many years, how many DCCs is that? That would be 1, 2, 3, 4, 5, and 6, right? Oh, I probably shouldn't have used orange. Let me just erase them. Let's not use orange. Let's use pink. 1, 2, 3, 4, 5, 6. And then it's about a matter of 2000. In 2000, then the AHA is $200,000, which is this line over here. So what can be afforded? You can afford this one. You can also afford this one. You can afford this one, and this one, and this one, and this one. So that will be what? 6 years as well, right? 1, 2, 3, 4, 5, 6. So 6 years for 1990, 6 years for 2000. Then how about 2010? And that's when things get tricky, right? Not tricky, but it's just about how we count it. So obviously you can't afford these big boys over here, right? You just can't afford them. So what can you afford? The first one you can afford is this one over here, 35. So this is the first one you can afford, and this is the second one you can afford, right? 40, and this is the third one you can afford, so 45. So in 2010, really there are only 3 DCCs you can afford, compared to in 1990 and 2000, you can afford 6 DCCs. So comparing those things all together, you can see that which of the following years, that would be 2000 and 1990 equally. Right? You would be D. So 1990 and 2000 equally, you can afford 6 DCCs. Compared to 2010, you can afford only 3 DCCs. All right, so that's pretty much all I want to talk about for this question as well. As you can see, the principle of quantitative reasoning isn't hard. It's not, it does not really have huge numbers, really difficult math calculations you gotta do. It's just about finding the right information and in a quick and efficient way, right? Because the greatest difficulty lies with the time pressure. Under time pressure, you don't have the time to read and process everything you see here in this much detail that we went through. But I hope just by, like, as I said, the units and the titles, most important things, just, you know, sort of think about what are the most important elements you want to get out of these information and just move on to the questions is, I hope, something you can develop during your preparation for the ISAT. All right, so that concludes today's video on just going through some quantitative reasoning questions. If you wanna, so currently we as a team, Medict is amending the question bank. So a new version for 2023 will be coming soon, and we are adding more questions to it. And if you are interested in finding out more about the question bank, now it has 1,000 questions, but we hope to expand it to 1,200 or 1,400, but we keep the same price. Is you can find it out from the medict.com So if you want to check it out, you can check it out on our website, medic.com.au. And this document is also free for download. It has answers attached at the back, so you can self-check and self-assess. Yeah, and also this one not only has quantitative, it also has some critical reasoning questions as well. So like this one about Kanye West, interestingly, and these ones, so quotes questions and categorization questions. I hope you have learned something from today's video. I don't know how long it is going, so I hope it's not too long, and I hope it's not too boring. It's just me talking and going through questions. Yeah, so I hope to see you guys in the next video, which is something I hope to put out by next week.